So hello everyone, this is one more video of the most expected archive series, and again we have Newton's laws of motion. Here it is from JEE Advanced 2009, the then IIT JEE. Let's see what the question is asking. It says a piece of wire is bent in the shape of a parabola. So we have a piece of wire in this form and the equation of parabola is given to be kx square. Okay, suppose this is our y axis and this is our x. Fine. Okay, this will pass through the origin anyways. The thing is, with a bead of mass m on it, so it has a bead of mass m also. The bead can slide on the wire without friction, so friction is not there. It stays at the lowest point of the parabola when the wire is at rest. So basically wire is at rest, the bead stays here. Bead means a kind of ring or something. The wire is now accelerated parallel to x-axis. So what happens? You have this wire, you accelerated it parallel to x-axis. So this is the acceleration, for example, this is the acceleration A. So what will happen? You'll say, sir, the bead that was at this point, because acceleration is towards right, so the bead will have centrifugal force towards left, for example, if you see in the frame of this parabola, isn't that? So it will reach somewhere here, isn't that? It will tend to remain behind, so it will reach here. So what will happen? For example, I have this this kind of a bead here, I hope you can visualize, and this was initially here, isn't that? And now parabola starts moving in rightwards. Fine. So this gets pushed like that, isn't that? It still has this tendency to leave this parabola, isn't that? So there will be a normal exerted by this parabola, this arm of parabola, that will be kind of inwards, isn't that? You can see that. So while making the free body diagram, you can see this is kind of a normal there, and there will be one more mg downwards, isn't that? And there will be a centrifugal ma with respect to the ring. Fine, because if we take the frame of reference to be the parabola, then we are in a non-inertial frame. Fine. Okay, and what else is given? It says when the wire is now accelerated parallel, okay, it accelerates the distance of the new equilibrium position of the bead, where the bead can stay at rest with respect to the wire from the y-axis is. Basically this is our y-axis, isn't that? So this distance is asked, basically the x distance is asked. Fine. So we can say, okay fine, kx square is also given. So basically it is a problem of differentiation. So we have to know what is the slope at this one point, considering that this parabola only touches one point, sorry, that this ring only touches one point. We can say this is the slope. Okay, I could not make it properly, you can visualize anyways. So if this is theta, for example, the left angle is theta, can we also say if this is normal, isn't that? This also will be theta. Can you see that? See, this was theta and there was one normal that was perpendicular to this, isn't that? This was the normal. If you make one more vertical axis here, isn't that? So if this is also 90, this is what? 90 minus theta. Okay, what is this? 90 minus theta, and this is also 90, so this is theta. Make sense? So can you write n cos theta should balance mg, and n sin theta should balance ma. This is the condition of net force in x comma y being 0, basically at equilibrium. Can you divide these two? Okay, let's divide the lower with the upper. So tan theta will come out to be a by g. So we got it. Fine, tan theta is a by g. Okay, one more data is given. See, because we visualized this theta and we equated that with this theta. So do we know what is the slope at that point? First of all, what is the slope at that point? The differentiation of this, isn't that? Because slope is the derivative is the slope at a point. So what is the differentiation of this? You will say, sir, it is 2kx. Makes sense? 2kx is y dash. Fine. That is the differentiation at that point. But that is also tan theta. Okay, but which theta we have to consider? Which angle? Not the theta, this one basically, because if your line is like that, this angle will give you the slope. So tan of this will give you the slope, the differentiation. Can we write? So our 2kx, okay, I'll write here, our 2kx, that is the differentiation, should be equivalent to 2kx should be equivalent to tan of, can we say this is pi minus theta? Yes, because this is theta. So pi minus theta. What is pi minus theta? So 2kx is, if you know these angle transformations, pi minus something is, okay, trigonometric ratio won't change. So tan of theta, but minus tan theta, because in second quadrant tan is negative. Fine. And what is our tan theta? We already got it, a by g. So can we say our 2kx is minus a by g? And what is our x now? Our x came out to be a by 2kg, and this is our x component, isn't that? And minus is also there because we took our angle from here, na? We put positive acceleration. If we did the other thing, for example, acceleration was in this direction, we'll get positive x for that, isn't that? Anyways, we only have to take the distance from y-axis, that is just the magnitude. So I think this is the correct option for this problem, and I hope this problem is like most expected to get repeated in JEE Mains as well as JEE Advanced sometimes. JEE Advanced has also asked this problem twice, so this can be repeated in future also. So best of luck for this problem.